transformations today. There are three different types that we're going to look at. There are translations, which are a type of transformation. There are reflections, again, another type of transformation. And then we've got down here some dilations, again, another type of transformation. Horizontal and vertical translations, a lot of times we call it a shift. You can shift up, down, left, right, and your x's go left and right. So if you have something added or subtracted onto the x, then it will move like x's do, either to the right or to the left. And then we have y values that go up and down. If you add or subtract to the y value, which f of x is a y value, if you're adding or subtracting onto that, then it will shift everything either up or down. Okay, so we're going to look at this function f of x equals 2x plus 1. And it says write a function g whose graph is a translation 3 units down of the graph of f. So this function g, I'm going to call it g of x. If it is getting shifted down, that means you have to subtract outside of the whole function. So I'm going to take the entire 2x plus 1 and I'm going to subtract 3 outside of that to shift it all down 3. So if I simplify this, that means my g of x is 2x minus 2. On my graph, what that looks like is it still has a slope of 2, but it hits the y-intercept at -2. Here is my graph for the g of x function. All right, so at this point you can pause and then try number 2. Go ahead and turn it back on and see if you got it right. All right, so for number 2, it says write a function h whose graph is a translation 2 units to the left of the graph of f of x. Because it says 2 units to the left, that means I do have to add this number in the parentheses with the x. It's an h function, so we will do h of x equals 2 times x plus 2 plus 1. So to simplify this down, we are going to get 2 times x and 2 times 2. It's distributed to both. So we got a 4 here, still with a plus 1 on the end there. So our final h of x function is 2x plus 5. Okay, so let's look at this on our graph. Y-intercept at 5 and a slope of 2. This is our h of x function. It got shifted 2 units to the left, which it kind of makes sense. If you look at the original graph, it went 2 units to the left. Okay, so those were our translations or our shifts, up, down, left, right. We can also do reflections. So if you have a reflection over the x-axis, then you have a negative multiplied in front of the f of x. It's like you're changing the sign on all the y values. So to reflect over the y-axis, the negative is on the x. You are changing the sign of all of the x values. So this time our f of x is the absolute value of x plus 3 plus 1, and they give us the graph over here. They want us to write a function g whose graph is a reflection of f over the x-axis. If I'm going to go over the x-axis, I have to put a negative in front of this entire function. And I mean the entire function, the entire absolute value of x plus 3 plus 1. That whole thing, I'm going to put a negative in front of it to get my new g of x function. Now I do have to distribute the negative. So that means my g of x function is negative absolute value of x plus 3 and then a -1. All right, so as far as the graph goes, it's a reflection over the x-axis, which means here's our x-axis. This was up at a +4, so instead of being 4 above, I'm going to be 1, 2, 3, 4 below the x-axis. It was reflected over to the other side of the x-axis. This point right here is a distance of 1 above the x-axis. It will now be a distance of 1 below the x-axis. This point right here, that is 1, 2 above the x-axis, so we're going to go 2 below the x-axis. So this should be our new function. This was the g of x function, and that was reflection over the x-axis. Next up, let's look at doing a reflection over the y-axis. That means you've got to put a negative with the x in your function. So I will have a negative x plus 3 and then plus 1. Here is my h of x function. There's not much simplifying to do on this one. This is my h of x function. And what that looks like on the graph is it was reflected over the y-axis. So here's my y-axis. The point that was touching the y-axis is going to stay there. So the point 0,4 still there. But each of these points, I'm going to count how far it is to the left of the y-axis. So this was 3 to the left. I will go 1, 2, 3 to the right of the y-axis. Okay, so that's a reflection of that point. This one was 1, 2, 3, 4 to the left of the y-axis. So I'll go 1, 2, 3, 4 to the right of the y-axis. And here's going to be our new graph reflected over the y-axis. Okay, so we've done some translations, we've done reflections. Let's look at dilations. Okay, so for dilations, you can also think of it as like a stretch or shrink. Your a is multiplied this time. It's multiplied by the x, like inside the function. And when that happens, it'll be a horizontal stretch or shrink because it's multiplied by x. X's go horizontally. So it'll be a horizontal stretch or shrink. And it'll stretch or shrink by 1 over a. I'll look at this stuff down here in a second, but the other one says that if your a that you're multiplying by is outside the function, then it's going to mess with your y values. It will stretch or shrink vertically, like y values go up and down vertically. And it'll stretch or shrink by a. It's not the 1 over a, like the horizontal dilation was. The vertical dilation is just a factor of a. So let's look at what happens here. Here's your function, your f of x function, x squared minus 1, and you've got the graph over here. So write a function g whose graph is a horizontal shrink by a factor of 1/2. Because it's horizontal, I've got to put it on the x, and the it that I'm multiplying by the x is the reciprocal of 1/2. See how it went from a to 1 over a? That's because it did a reciprocal, it like flips the fraction. So that's what I'm going to do here. I'm going to do a reciprocal of 1/2, and I'm going to have, instead of 1 over 2, I'm going to get 2 over 1, or the whole number 2. I'm going to, again, put that 2 multiplied by the x. So I will have a 2x squared minus 1 is my g of x function. Graphically, what this means is my a value, which we subbed a 2 in for the a, 2 is greater than 1, so this will be a horizontal shrink. Like horizontally, left and right, is going to shrink toward the y-axis. So let's look at what happens here. This that was 1 away from the y-axis, I'm going to go half that. I'm going to go to a positive 1/2. This number over here that was 2 away from my y-axis, I'm going to do half of that. It's going to go into the 1. And the same thing on the other side. 0, if it's 0 away from the y-axis, half of 0 is still 0. So it's still right on the y-axis there. And we can connect these. This is our g of x function. And this was a shrink. It's like it got condensed smaller horizontally. So number 6 here, you've got an h of x function, and the graph is a vertical stretch by a factor of 3. In order to have a stretch, your a has to be greater than 1, which in this case, it's a 3. 3 is greater than 1. So we are going to put that 3 in for the a. We've got 3 times our function, times the entire function. So 3 times the entire x squared minus 1. We can distribute that 3 times x squared and 3 times the negative 1. So that would give us 3x squared minus 3. Okay, so there's our h of x function, and it should be a vertical stretch by a factor of 3. This would be like you're taking these endpoints and you're like stretching it vertically. It's like you're grabbing and pulling those up. So let's see what that looks like. We are going to multiply each of our y values. Again, this was a vertical stretch. Vertical has to do with y values. We're going to multiply each of our y values by 3. So this y value right here was negative 1. Negative 1 times 3 is negative 3. So that got like stretched down to a negative 3. Same x value, just change the y value. 0 times 3 is still 3. So those are still going to stay there. 3 times 3 is 9. It's like it got stretched all the way up to a 9. Same here, this y value of 3 times 3 goes up to a 9. This is going to be, like we said, a stretch, a vertical stretch. So this will be longer, skinnier. That was a stretch of our h of x function.